Hi my dear student, today we will discuss about introduction of trigonometry. Already we discussed this topic in 10th standard. With the trigonometric ratio, sine, cos, tan, cosecant, secant and cot. Mainly we discussed about the degrees 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Now we will see a small review about what we discussed in 10th standard. We have a triangle which is a right angle triangle. I'll take A, B, C, 90 degree at B, and this is an angle theta. When I'm considering this is an angle theta, this will be opposite side and this will be adjacent side, and this is always hypotenuse. And what is sine theta? The ratio of opposite and hypotenuse. What is cos theta? Ratio of adjacent and hypotenuse. What is tan theta? Ratio of opposite and adjacent. What is cosecant theta? Which is the reciprocal of sine theta. That is hypotenuse by opposite. What is secant theta? Which is the reciprocal of cos theta, which is hypotenuse by adjacent. What is cot theta? Which is the reciprocal of tan theta, which is nothing but adjacent by opposite. Okay. So in trigonometry we have 6 functions, namely sine, cos, tan, cosecant, secant and cot. Here sine and cos, which is the ratio of opposite hypotenuse and adjacent by hypotenuse. Tan, sine divided by cos. When you divide sine theta divided by cos theta, it gives tan theta. And cosecant theta, which is the reciprocal of sine theta. Secant theta, which is the reciprocal of cos theta. Cot theta, which is the reciprocal of tan theta. Is it clear? And mainly we discussed the trigonometric ratio of an angle 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Now let us see. See, 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Very first, sine function, cosine function, then tan function. How to fill up this table in a simple way is, in standard degree, I use 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. I have 1, 2, 3, 4, 5 values. So I will consider from 0, 1, 2, 3, 4. I have 4 quadrants. I will divide by 4 everywhere. Take a square root. That's all. 0 divided by 4 is 0. Square root will be 0. Square root of 1 will be 1. 4 will be 2. And 2 by 4. This 2 cancel here 2 times. Square root of 1 will be 1. Square root of 2 will be square root of 2. Square root of 3 will be 3. Square root of 4 will be 2. 4 get cancel 1. Square root of 1 will be 1. Write this value for sine. That's all. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. For cos theta, reverse of sine. 1 will come here, root 3 by 2, 1 by root 2, 1 by 2, 0. You are writing 0, 1 by 2, 1 by root 2, root 3 by 2, 1. For reverse of this one, 1, root 3 by 2, 1 by root 2, 1 by root 2 and 0 will be cos theta. What is tan theta? Sine divided by cos. So 0 divided by 1, 0. 2 cancel. 1 by root 3. 1 by root 2, 1 by root 2 get cancelled. 1. 2 cancel. Root 3. 1 divided by 0 is infinity. Is it clear? Here sin theta, cos theta, tan theta with respect to 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. It's a very easy way to remember. Very simple. Write 0, 1, 2, 3, 4. Divide 4 everywhere. Simplify, take a square root. It gives 0 by 4, 0. Square root of 0 will be 0. Square root of 1 will be 1, square root of 4 will be 2. That is 1 by 2. Here when you simplify 1 by 2, after taking square root of 1 will be 1, square root of 2 will be square root of 2. That is 1 by root 2. For square root of 3 will be square root of 3, square root of 4 will be 2. That is root 3 by 2. And it get cancelled, 1, square root of 1 will be 1. This gives the sine function with respect to 0, 30, 45, 60 and 90 degree. When you write in reverse order, it gives cosine. 1, root 3 by 2, 1 by root 2, 1 by 2, 0. When you divide sine and cos, it gives the tan theta value, that is 0, 1 by root 3, 1 root 3 and infinity. For finding cosecant theta, which is the reciprocal of sine theta. For secant theta, which is the reciprocal of cos theta. For cot theta, which is the reciprocal of tan theta. Many students getting confusion. The reciprocal of sine or the cos gives cosecant or secant. Very easy. Remember, this is cosecant, C. Here S will come, sine theta. Here secant theta, yes. Here C will come, ulta. Is it clear? For sine theta, reciprocal gives cosecant theta. For cos theta, reciprocal gives secant theta. Here C means here S. Here S means here C. Got it? Sine, cos, tan are the trigonometric functions whose reciprocal are cosecant, secant and cot. Is it clear? In 10th standard, we discuss about only few degrees which are standard, which is nothing but 0, 30, 45, 60 and 90. Now, in 11th standard, we are going to discuss n degrees where n belongs to real number. Not only we are going to discuss the standard degrees like 0, 30, 45, 60 and 90. Here we are going to discuss after 90, 100, 110, 200, 300, 400, 760, 780, 1000, 80,000, 150, 3000 degree, etc. We are going to discuss n degrees where n belongs to R. Is it clear? And this is a standard table in trigonometric ratio, and we used trigonometric ratio with the help of right angle triangle. Already I said sine theta, which is opposite by hypotenuse, cos theta, which is nothing but adjacent by hypotenuse, tan theta, which is nothing but opposite by adjacent. For cosecant, which is nothing but reciprocal of sine theta, that is hypotenuse by opposite. Secant theta, reciprocal of cos theta, that is hypotenuse by adjacent. Cot theta, which is reciprocal of tan theta, that is adjacent by opposite. Got it? Now we will see the basic structure of sine. Then only you can able to understand how we are going to climb n degrees. Is it clear? Now sine curve. This is sine curve. This is 0. This is 0 degree. This is 90 degree. 0, 30, 45, 60, 90. It gives the value of 1. Sine 90 gives 1. Already we discussed, no, sine 0. This is 0. This is 1. In between. This is 30 degree if I am assumed. This will be half. This is 45 degree means it gives 1 by root 2. This is 60 degree means it gives root 3 by 2. Very smaller. This is 30. Sine 0 gives 0. Sine 30 gives half. Sine 45 gives 1 by root 2. Sine 60 gives root 3 by 2. Sine 90 gives 1. Like that. This is 90 degree. And 100, 110, etc. This will be 180 degree. This will be 270 degree. This will be 360 degree. Okay. Hereafter I will use the measure as 180 degree approximately as pi. Okay. Pi denotes 180 degree. So I can write this as pi divided by 2. And this one as pi. This will be 2 pi. See, this 2 pi will be 360 degree. Got it? 360 degree is a one complete rotation. See, this is 0 degree. Okay. And it goes here 90 degree. 180 degree. This is called use in protector. And use close circle, it gives 270 degree, 360 degree. Okay. See, one complete rotation, 0 degree, 90 degree, 180 degree, 270 degree, this is 360 degree. See, 0 degree, 90 degree, 180 degree, 270, 360. Again after 360 degree, this is 1. Similarly this one. Same waves, like a wave motion. Okay. So after 360 degree, it gives the same values in same motion. Again 90, 180, 270, 360. Again it will go. So every 360 degree, 0 to 360 degree, it gives the same value in the positive direction, even in the negative direction. Okay. So after every 360 degree, it will come to the starting position. We want to understand this point. After every 360 degree, it will come to the starting position. This is like a wave motion. This is what sine curve. Sine 0 gives 0, sine 30 gives half, sine 45 gives 1 by root 2, sine 60 gives root 3 by 2, sine 90 gives 1. So after sine 90 degree, it comes down. Okay. When sine 180 degree comes, it will be 0. And sine 270 degree, it will come to the negative value of minus 1. Again it will increase, it will reaches 360 degree at 0 value. Okay. So like that it will go. So every 360 degree gives the same value. 360 degree is nothing but one complete rotation in the form of circle. Try to understand. Every 360 degree gives the same value, and 360 degree is nothing but one complete rotation in the form of a circle. See, 0, 90, 180, 270, 360. Is it clear? So every 360 degree it has the same rotation and it gives the same set of values. Okay. And this is the sine curve. Similarly, we have cosine curve. Very first I will explain sine curve. This is a sine curve, and here I explain about 0, 90, 180, 270, 360. It will be 360 plus 90, 450. It will be 1 pi, 2 pi, 3 pi. This will be 3 pi. It means 3 into 180, 540 degree. It will be plus 90. 540 plus 90, 630 degree. It will go. But after 360 degree, the values what you are getting, which appear here itself. Every 360 degree, the values will lies here itself. So what we are going to do, when you are going to find out after 360 degree, we will convert it to between 0 to 360. That is what I am going to explain now. Here I explain sine curve. Similarly, I want to explain cosine, tan, secant, cosecant, etc. But very first you should understand about sine curve. The sine curve will go like this. Okay. For 0, 90, 180, 270, 360, 450, 500, 700, 1000. Similarly, negative direction it will go here. Okay. Now, how we are going to find out the angle after 360 degree? Okay. That we will discuss. See, this is 0 degree, 90 degree, 180 degree, 270 degree, 360 degree. Okay, this is first quadrant, second quadrant, third quadrant, fourth quadrant. One complete rotation starts here, it will go, it will come here and then 360. So keep on, it will rotate. I will consider some theta which lies between 0 to 90 degree, or you can consider equal, no problem. I will consider theta is an angle whose value lies between 0 to 90 degree. Just keep in mind, I will consider an angle theta whose value lies between 0 to 90 degree. Okay. If I am going to subtract theta from 90, it will come here. It lies in the first quadrant because this is 0 to 90 degree. When I am going to subtract theta, what is meant by theta? Theta is an angle which takes a value from 0 to 90. If I am taking 1 degree, 90 minus 1 gives 89 degree. It will be here. If I am taking 50 degree, 90 minus 50 appear 40. It will be here. So anyway, 90 minus theta lies in first quadrant. 90 plus theta lies in second quadrant because theta value is 0 to 90 degree. When you add, it lies in the second quadrant. Suppose if you take the small angle like 1 degree, 90 plus 1, 91. Maximum of 89 when you take, it will be 179. It will be here. So 90 minus theta lies in first quadrant. 90 plus theta lies in second quadrant. Similarly, 180 minus theta. Theta is 0 to 90. 180 minus theta lies in third quadrant. When you subtract theta from 180, it lies here, second quadrant. 180 plus theta will be third quadrant. 180 plus, choose any value between 0 to 90, it lies here to here. 270 minus theta lies in third quadrant. 270, choose any value from 0 to 90, subtract, it lies in the third quadrant. 270 plus theta lies in fourth quadrant. When you add any value between 0 to 90 from 270, it lies in the fourth quadrant. When you subtract theta from 360, it lies in fourth quadrant. When you add 360 plus theta, it lies in first quadrant. Got it? Very simple and very important. I am going to consider theta whose value lies between 0 to 90 degree. Okay, and this is 0 degree, this is 90, 180, 270, 360. Again it will reach at 0 degree. When you add theta with 90 degree, when you add, it will come here, 90 plus theta. When you subtract, it will come here. 180, when you add, it will go to the third quadrant. When you subtract, it will come to the second quadrant. 270, when you add, it will move on to the next quadrant, fourth quadrant. When you subtract, it will come to the third quadrant. 360, when you add theta, it will come to the first quadrant, subtract, it will come to the fourth quadrant. Got it? This is what the basic structure. Next, you wanted to remember, in first quadrant, all your values are positive. All your values are positive. How do I know, sir? Yeah, very simple. This is x-axis and takes the value 0, 1, 2, 3, etc. And this is y-axis 0, 1, 2, 3, etc. These two boundaries gives the positive values. So, in first quadrant, all your trigonometric ratios are positive. That is what we discussed in 10th standard, 0, 30, 45, 60 and 90. Up to 90 degree, which is the first quadrant, it gives a positive value only in the table. Okay. But now we are going to discuss the values after 90 also, after 90, 180, 270, even 360, 360 plus etc. Okay. So why we are telling all your values in the first quadrant are positive? Because the boundaries takes only a positive, even x-axis and even y-axis. So in first quadrant, all your values of trigonometric ratios are strictly positive. In second quadrant, sine theta, whose reciprocal of cosecant theta, are positive. Sixth trigonometric ratio, where sine and cosecant only are positive. Third quadrant, tan function, whose reciprocal of cot function are strictly positive. Tan function, whose reciprocal of cot function are strictly positive. Fourth quadrant, cosine function, that is cos theta, and the reciprocal of cos theta, secant theta, are strictly positive. Well, I'll tell you the reason why I am telling in the particular quadrant these functions are only positive. Okay, and another way is how to remember this one. Okay, that I'll tell you later. So in first quadrant, all your trigonometric ratios, sine, cos, tan, cosecant, secant, cot, everything are positive. For second quadrant, sine theta and cosecant theta are positive. In second quadrant, sine theta and cosecant theta are positive. Okay, I'll tell you the reason. This is a sine curve. Now I'll explain why we are telling sine, cosecant, tan, cot, cos, secant respectively in the quadrant are positive or negative. Very first, sine curve. This is a simple structure of sine curve. Okay, it will go. And cosine curve. This is cosine curve. It starts from here and it will go like this. See, 0 degree gives 1 cosine and 90 degree it gives 0, and this will be 180, this will be 270, this will be 360. Try to understand. Cos 0 gives 1 and cos 30, 45, 60 it reduces. Cos 90 degree gives 0. Already we discussed in 10th standard. And for 180 degree it will come down. Cos 180 degree gives minus 1 and it will go up 270 degree and 360 degree. See, this is 0 to 360 degree of cosine curve. Got it? And after this one, the same value will be repeated. What I explained for sine curve. Similarly, here 0, 90, 180, 270, 360, it will be repeated. For cosine curve, it starts from here because cos 0 gives 1 and cos 90 gives 0. For cos 180 gives minus 1. It will go. Okay. This is the structure of cosine curve. Now, with the help of sine curve and cosine curve only, we are going to say in the respective quadrants, the respective functions are positive, negative. See, this is sine curve. I'll explain. 0 to 90, 180. So, 0 to 180, sine are positive above x-axis. The values appear for sine curve from 0 to 180 degree above x-axis. It is positive. 0 to 180 degree. This is 0, 90, 180. So, up to 0 to 180, sine already here positive, here also positive. See, 180 to 270, it appears below x-axis. So, sine negative here. So, in third quadrant, tan theta and cot theta, what I written here are positive. Other four functions are negative. So, 180 to 270, 270 to 360, the sine value below x-axis. So, from here, 180 to 360, sine negative, here also sine negative. That's why I said tan, cot, cos, secant respectively are positive. So, very first I will explain about sine values. In this sine curve, 0 to 90, 180 above x-axis. So, your first quadrant sine positive, even in second quadrant sine is positive. From 180 to 360, it lies below x-axis. So, here sine negative, here also sine negative. So, according to sine theta, the reciprocal of sine gives cosecant theta. The cosecant theta also positive in first quadrant, even in second quadrant, because we are getting the value of cosecant by taking the reciprocal of sine. So, when you take a value as a reciprocal, there is no change in the sign. Maybe the value will be different, but the sign never changes when you take a reciprocal. So, what is sin theta in second quadrant? Positive. Even cosecant theta also positive. In third and fourth quadrant, sin theta are negative. Therefore, cosecant theta also negative. Got it? Is it clear? Now come to cosine curve. 0 to 90 degree. It lies above x-axis. See, this is the structure of cosine curve. 0 to 90 degree, the values appear above x-axis. Above x-axis. So, above x-axis means positive. So, this is 0 to 90 degree. Already I said all your trigonometric functions are positive. So, 0 to 90 degree cosine positive with the help of cosine curve. And see the same cosine curve. 90 degree, 180 degree, 270. From 90 to 270, the value lies below x-axis. From the cosine curve, 90 degree to 270 degree, the value lies below x-axis. Below x-axis means what? It gives a negative value. So, after 90 till 270, 90 degree, 180 degree, 270. So, in second quadrant and third quadrant, cosine are negative. Here also cosine are negative. See, no cosine function I wrote here. So, cosine, cos theta is negative in second quadrant and third quadrant because from 90 to 270, the value of cosine will be negative because it lies below x-axis. So, I can say in second quadrant and third quadrant, cosine values are negative. See, 270 to 360 it lies above x-axis. It gives a positive value. So, 270 to 360, cos theta is positive. Cos theta is positive. Now, can you understand why I am telling sine is positive here and negative here, cos is positive here, but negative here and negative here because of the sine curve and the cosine curve. Got it? I will repeat. See, this is a cosine curve. From 0 to 90 degree, it lies above x-axis. So, it gives a positive value in the first quadrant. So, cosine is positive. From 90 to 270, the value of cosine lies below x-axis. It gives a negative value. So, after 90 till 270, cosine is negative. Cosine, second quadrant, cos theta is negative. Third quadrant, cos theta is negative. That's why I didn't mention. And 270 to 360, it lies above x-axis. So, when it lies above x-axis, which gives a positive value, 270 to 360, cos is positive. Okay. Similarly, what is the reciprocal of cos? Which gives secant theta. So, when cos theta is negative in second quadrant, the reciprocal of cos secant theta is negative here, even in third quadrant. But in fourth quadrant, cos theta is positive. Reciprocal gives secant theta, which is also positive. So, can you understand why we are writing cos theta is positive in fourth quadrant and secant theta is positive in fourth quadrant? Because second quadrant and third quadrant, cosine is negative, whose reciprocal of cosine, that is, it gives secant theta, which is also negative. That's why in second quadrant and third quadrant, cos and secant are negative. In fourth quadrant, 270 to 360, it lies above x-axis. So cosine is positive, whose reciprocal secant theta is also positive. Got it? Now you can understand about sine, cosecant, cos, secant. Here we discuss sine, cos, cosecant, secant. Now tan. What is tan theta? Tan theta, which is nothing but sine theta by cos theta. In first quadrant, sine is positive, cos is positive, positive by positive, positive. So tan is positive, no problem. Already I said all your trigonometric functions are positive. In second quadrant, sine is positive. Got it? Sine is positive, but cos is negative. When you divide, plus divided by minus, it gives minus. Got it? In second quadrant, sine is positive, but cos is negative. Positive by negative gives negative. Therefore, tan theta is negative in second quadrant. In third quadrant, sine negative, cos also negative. Negative by negative gives positive. Therefore, in third quadrant, tan theta is positive. Got it? Why I am telling third quadrant tan theta is positive? Because tan theta is nothing but sine divided by cos. In third quadrant, sine theta is negative. In third quadrant, cos theta is negative. Negative by negative gives positive value. Therefore, in third quadrant, tan theta is positive. And fourth quadrant, sine theta is negative, but cos theta is positive. Negative by positive gives negative. Therefore, in fourth quadrant, tan theta is negative. So here I mention sine, cosecant, tan, cot, cos, secant, which is nothing but in the respective quadrant these functions are positive. Other than these two, the remaining four trigonometric functions are strictly negative. This is what the reason why I am telling tan theta is positive in third quadrant and negative in second and fourth quadrant. Even in first quadrant it is positive. And the reciprocal of tan theta gives cot theta. So obviously the same sign will appear. Therefore cot theta is negative in second quadrant and fourth quadrant, but cot theta is positive in third quadrant and first quadrant. So now can you understand why we are telling all your trigonometric functions are positive in the first quadrant? Because all your values, I mean the output of sine theta, cos theta, the division of sine and cos tan theta, the reciprocals are always above x-axis. That's why in first quadrant all your trigonometric functions are positive. In second quadrant, sine theta value between 90 to 180 are positive. Therefore the reciprocal is positive. But other values of tan, cot, cosecant, secant and all, when you discuss with the help of sine and cosine curve, it gives the negative value. That's why in second quadrant sine and cosecant theta are strictly positive. In third quadrant, tan theta and cot theta are positive, because in third quadrant, that is 180 to 270, sine gives negative, even cos gives negative. So negative by negative gives positive. So in this particular quadrant, the tan theta and cot theta values are positive. The remaining four trigonometric functions like sine, cosecant, cos, secant and all negative. In fourth quadrant, when you see the cosine curve, it gives a positive value, and the reciprocal of secant is also positive. The remaining values of sine, c and negative by positive, which gives in tan also negative. So in fourth quadrant, cos and secant are positive. The other four trigonometric functions of sine, cosecant, tan, cot and are negative. Is it clear? People will say how to remember this one. That doesn't matter. That I'll tell you later on. But you should know why we are telling particularly in this quadrant the trigonometric functions, all trigonometric functions are positive. I mean in first quadrant. In second quadrant, sine and cosecant is positive. What is the reason? In fourth quadrant, cos and secant are positive. What is the reason? Similarly, in third quadrant, why we are telling tan and cot are positive? Because of everything which is based on sine curve and cosine curve. I am not making confusion between you. Very simple. With the help of sine curve and cosine curve, I can say the function which are positive or negative in the respective quadrants. Easily you can be able to identify. This is what the general structure of sine curve. Already I explained. It will go like this. Keep on. Similarly this side, even in cosine curve, it starts from here, because cos 0 gives 1, cos 90 gives 0, it will go keep on. Okay, this is a structure of cosine curve. With the help of sine curve and cosine curve only, we declared why the functions are positive or negative in the respective quadrants. Really you should know the reason why we are telling the functions are strictly positive and negative in the respective quadrant. You should know the real reason. This is what the real reason. Okay, and how to remember? My simple way is just remember the word all. All students know. All students take Which is your favorite drink? Coffee or Complan? Okay, so which coffee or Complan? See the letters all. A double L. Student, yes. S means sine theta, whose reciprocal cosecant theta, SC. Take, T. T for take, that is tan theta, whose reciprocal cot theta. Coffee or Complan. C, whose that is cos theta, whose reciprocal secant theta. So all students take coffee or Complan. So it's easy to remember. All students take Complan. All means all your trigonometric functions are positive. Student, yes. Sin theta whose reciprocal cosecant theta is positive. Take, T. Tan theta whose reciprocal cot theta is positive. Coffee, C. Cos theta whose reciprocal secant theta are positive. Got it? This is the easy way to remember, but real reason why we are telling these functions are positive or negative according to the quadrant, which is based on complete sine curve and cosine curve. Here I didn't explain actually tan, cosecant, secant and all. Okay, very beginning stage, with the help of sine curve and cosine curve itself, we can able to declare the functions are positive or negative according to the quadrant. Is it clear? It's very important. This is not only in 11th standard, even when you are going to do in your problems or working in engineering also, it is very important. You should know the real reason why we are telling the functions are positive or negative according to the quadrant, which is completely based on the diagram. In part 1 video, we discussed about the trigonometric ratio of sine, cos, tan, whose reciprocal of cosecant, secant and cot with the help of right angle triangle, that is the ratios opposite, adjacent, hypotenuse, etc. And we discussed sine curve and cosine curve basic structure. With the help of these two basic structure, how can you define the functions are positive according to the quadrants? That is what we discussed. In part 2, we will discuss how to find out the trigonometric functions whose values after 90 degree. Already in 10th standard we discussed between 0 to 90 degree in a standard degrees like 0, 30, 45, 60 and 90. Now how to calculate the value after 90 degree for the respective trigonometric function. We will discuss in part 2. Got it?